സച്ചിൻ മുരളി ഗോകുലം. ആരുമല്ല, നമ്മുടെ ലുമിനി തന്നെയാണ്. നമ്മുടെ 2013 he's passed out from our college to I think 2013 passed out ആണ് BTech. After that, he has done masters in computer science from University of College Cork, Ireland. അത് കഴിഞ്ഞിട്ട് അതിന്റെ ഇടയ്ക്കാണ് പുള്ളി he started his career in some of the Indian companies, and then I think he moved to Ireland, and he has worked in multiple companies, and now he is working in Amazon Web Services Dublin in Ireland as a software development engineer. So there are a lot of things to learn from him. He is just working in AWS, so none other than a person who is working directly in Amazon itself, right? So you have a great opportunity here to learn from the person who is working in the company itself, right? So I would like you all to use the opportunity. Before going to the the session, I just want to talk about a little bit more about Sachin. Sachin is not just great in academics and his role, but he's also good in sports. When I was going through his profile, he's a very good badminton. He represented Kerala State for national kickboxing tournament. He has been part of many bad clubs like Ericsson Badminton Club, former member of UCC badminton team, and he has been part of NSS national camp. And also he is not he is a kind of an person who is in tech industry as well as sports. So I think he is a multi-talented person. So without further ado, inviting Mr. Sachin Murali for his session. Thank you.
Hello guys. Upon എൻ്റെ പേര് സച്ചിൻ. I understand there are some non-Malayali speakers here, so I'll switch my medium to English. Thank you, Shamirka, for the introduction, and I thank the GECW, especially like Arjunatan and everyone for inviting me for this session. And I see IEEE has kicked off a great deal in GECW that makes me proud, actually. It's a great initiative, and I appreciate everyone who's a part of IEEE, and I encourage everyone to join that, actually. And I see my teachers here as well, like Gilesh sir and Srijit sir. I just saw them here on the pictures. So yeah, it's an honor for me as well to be a part of this. So I thank everyone for inviting me to this. I think I'll share my screen now. I have prepared a slide deck, so hopefully. Sorry, just a second. I'm just sharing my. I have to rejoin the meeting. I have a permission issue. Just a second. Sorry about this.
No problem.
It's there. Now presenting again. I hope everyone can see my screen now.
It's loading, Sachin. Yeah, we can see. Yes.
Okay, so I'm sharing the entire screen. Okay, so today I've designed a slide like this. So I'm going to talk about a little bit about how to train your Android. So I hope everyone have seen this movie, How to Train Your Dragon. So it's a story about Hiccup, a dragon who has a small bug with with his tail, and then the main character of the story does hacks on him and then makes him a really powerful dragon. So I myself personally see Android phones like this, like it's a small device. It's a small device, but it has a lot of potential in it. And by knowing how to train it, by knowing the underlying working of it and how to code it, it can be a really powerful device that you carry around, powerful tool that you carry around with you all the time. So this is my I was given a brief introduction, and this is my career path from from BTech in Government Engineering College Wynad all the way to my present role in AWS here in Dublin. And while doing these roles, I had a couple of Android development exposures, especially from while I was working in Sultan Bateri for Netram IIC. That's when I was first introduced into the Android development environment for developing software in telecoms. And then I also had a bit of exposure in when I was working as a senior software engineer at Fiserv. So there we made payment devices. So it's payment devices, which was a direct clone of Android operating system. And then we made software on top of that so that it can read your card for making payments in multiple venues, and also the backend of it as well. So the slide today, the deck today I'm presenting is like more like a way of working on Android and an introduction to the development itself. At any point, if I'm going too fast or too slow or something, please do interrupt me and let me know over the pace. And so I'll step into today's topics. This is like kind of like today's show. So I'm planning to cover Android software stack and development intro. I really think it's important to know the stack before diving into the development itself. 1 hour may not be big time, may not be enough time to actually walk anyone through the whole Android development. So my aim is to make everyone here have enough capability to Google what are the stuff to do in Android, or what are the topics that can be done in Android, like what is the right keywords in that can be Googled to know more about the software. I also want to talk a little bit about source code management and collaboration. I'll be using Git in this presentation as well. So Git is really important. Like if you are working in any company, this is the tool everyone is using at the moment. There are other tools like SVN and Mercurial as well, but I really think Git is the industry standard by de facto at this point of time. And then we will go ahead and create a small calculator application in your personal computer. As in, I'll demo that, and the code is up in GitHub, so you can clone and modify that later on. And then I'll give a small intro on something that you can try yourself as well, like a to-do list application, which I'll talk about in the end. And then I'll open it up for a Q&A session where you can ask more questions to me, like any kind of questions to me. And so for getting started, first, these are the basic steps to start development in Android. These are the basic steps that you might have to go through. Like you'll have to download and install the Android Studio. You have to create a new project. Then you can try run an Hello World code in Android virtual machine, and then you push up your code into the GitHub. So I have recorded myself doing all this, so I'll shortly present that. So downloading Android Studio, it's straightforward. Like I don't think I have to present this, but still I just want to introduce you guys to the Android developers website. I hope everyone here is familiar with Java development, because I am assuming that everybody is familiar with Java development. That's why I'm setting the course in Java. So Android developer is a website where you can find everything, like A to Z, whatever details you need, it is available in Android developer's website. So I just wanted to show this website, and I just want to introduce this website to you. So a software's or any software success depend on the amount of documentation it has, especially if it is catered for developers. So the more documentation you have, the more chance of people using it. So same goes for Android Studio. So same goes for Android. The Android developer.android.com website has everything you need for to everything. It's a dictionary for Android. It's a single source of truth for all your Android questions. Whatever you need, it's available for reference in developer.android.com. So, and you also get to download an Android Studio IDE from the developers.android.com website. And IDE is an integrated development environment where you can build, develop, and test your software. It also have deployment and the version control capability. So Android Studio is your one-stop for all the development needs. And the developer.android Studio is your one-stop for all your references. So after you download and install, it's a straightforward procedure. You can download and install, and then install Android Studio from the developer.android.com website. And then installing is dependent. So my machine is Mac, so I'm going to skip that video for now. And when you open the Android Studio, it'll ask you a couple of questions. So it's a straightforward procedure again. Once you run it, it'll load and it'll ask for just a couple of settings, and it's just a straightforward wizard where you can select your preferences and everything. And once you hit finish, it'll download a lot of stuff. Like it'll download a bunch of stuff from the various repositories. And once you are done with that, you can start a new project. So creating a new project is again straightforward. So once you open the Android Studio, you can select create new project from here. So if you click start a new Android Studio project, then you will come to a screen like this. So Android is a very versatile operating system. It's based on the Linux kernel, and it can run on a bunch of things. Like for example, it can run on phone and tablet, which you can see here. And then it can also run on a bunch of other stuff. Like for example, Wear OS, which is like for the watch, for a watch that you wear. Not just the watches. There are a bunch of other stuff as well, like pocket watches and everything. So all those devices are catered by Android as well. So you can run it on a TV or recently Volvo launched a car, the Polar series, where the entire car runs on Android, and Android things is for IoT. So Android is a really powerful operating system. It runs on a bunch of things. But for today's session, I'm concentrating more on the phone and tablet development, because that is like a break-in, like an icebreaker to the whole development environment. So your Android today is capable of developing application for all those devices. And the moment when you click next there, you are presented with with a bunch of text boxes, which asks for a name for your application, where you can provide a specific package name. This package name is very important, as in when you publish an application to Google Play Store, for example, this is like a unique ID for your application. So we use a naming convention called as a reverse domain name convention, where the sachinmuraliji.me is my personal website. So I'll be using me.sachinmuraliji.myapplication as a package name for my application. This will be unique across the whole globe. So only you will be owning that particular domain name. And then so after you give your name here, you can give a save location, and then you can also switch between two languages there. So you can see Java and Kotlin. So you can switch between Java and Kotlin there. So I'm choosing Java for this particular series because most of you will be familiar with Java, but the industry is shifting towards Kotlin. So most of the code written now, they're being translated to Kotlin just because it is more expressive. Like you write less code, but you get more out of it, and it is better for handling some exceptions. Like it altogether avoids exceptions like null pointer exceptions and everything. So Kotlin is a really powerful language as well. But for simplicity, for now, I'm sticking with Java. And also you can choose which Android versions on which all Android versions should your application be supported. As in, is it just Android Lollipop? Like Lollipop is like the base OS now, I guess. As in, most of the devices are on versions above Lollipop. So it shows, so you can choose which operating system your device should run on, and it will show the percentage of devices around the globe that will support your application as well. Like for example, if I choose Lollipop, 94.1% of devices across the world will be able to run my application. So once that particular choice is made, it is a very important choice as well. In many industry, this is a very critical decision that is made, like which version of Android should it at the bare minimum support. And once you click finish, it'll start doing the build operation and everything. So you'll see there's a couple of processes running at the bottom. And once that is done, the view on the left side will refresh, and it will highlight the files relevant for your Android. So if you are a first-time Android developer, this is the place where you get a bit overwhelmed. As in, there's too many files, there's so many things going on, there's too many displays running around. So this is a point where everybody gets overwhelmed. But when you dwell deep into it, it's not that hard. It'll all start making sense. So after creating a new project, you can straight away. So this is a boilerplate code, as in your IDE has already created everything that you need to run this application at the moment. So if you straight away click run, it will automatically, like, this will run a hello world program on your system. So it'll first compile your application, and then the Android Studio also comes with a very nice tool called Android Virtual Devices, where you can virtually run any phone, any Android phone on your system. So, for example, here I'm starting up a Nexus 5X with API 28 here. So, but you can you can run whatever device you want in your system using Android Virtual Device, the device manager. You can create, so it's a small icon on the top here. So you can open that and you can create whatever devices you want. The purpose of this is that even if you write a code, even if you have, you most probably will have only one phone to test your application. So to make sure your application runs on all the devices as expected, you might need to run it on virtual devices. And when you scale things up again, one more step, you will have, for example, in Amazon, we have device farms where you can buy a set of devices in Amazon, and then you can put your application into it and test the whole thing out. So but for a beginner, this is the way to go. Like, you can have your own phone connected, or you can have a virtual device that is running your application. So if I run this application without doing anything, just by creating a new project, it will start up a hello world application in a phone. You can run this on your phone as well if your phone is connected and developer options are enabled. Then you can straight away run this application on your phone as well. And once this setup is done, the next step, this is an important step. It's important to push it up into a remote repository. So as in to version control. I'm not sure how many of you have accounts in GitHub, but if you don't have, create an account in GitHub or in GitLab or in Bitbucket, and make sure you practice version controlling before you start, or at least the moment you start anything, like maybe your resume, maybe your document or latex project presentations or whatever it is. Make sure it's all version controlled. Version control is really important because when I was doing my bachelor's, we used to have folder names like final, final 1, final 2, final, finalist, final, and then there will be a bunch of copies of it. And when we collaborate with our colleagues, we won't have the right version of the document or a software that we're presenting. This eliminates a lot of that. So this is like your remote repository is a single source of truth, and everyone can collaborate. It's like a Facebook for coding. So you can use multiple repositories. GitHub is now taken over by Microsoft. So some people have things against that. So you can use GitLab. GitLab even provide you a free CI/CD function. I will talk a little bit about CI/CD towards the end. So once you have your GitHub account, we can create a repository, create a name, and then you can decide if it's public or private. Public is when everybody on the internet has access to your repo. They can see your repository, and you can choose who can contribute to it as well. Most of the open source repositories are public. Private is when you're doing your college project or something, you might want it as a private one. So it will be just among you guys, your team, who is going to contribute to this code, and your professor who is going to review your code, or who you're submitting it to. And it's all again straightforward. So once you create a repository, and it'll show a bunch of commands. For example, here you can see Like it shows a window with all the commands that is needed to push up your repository. So Git is a tool that you can download from gitsem.org. So you can just Google and you can download it on systems on I think most of the Linux distros, and in Mac it comes de facto. And Windows you can download it and install. And once you have it installed, you can just cd into your directory and run these following commands to push your code up into the repository. So you can see it here. I'm just showing how to push up my repository, my current code base. I'll be pushing up in this video. So you can see I'll just go into the directory where the project is located, and then I'll run the commands in sequence. So I'll just briefly walk through the commands here. So git init is to initialize the repository. That is to ask Git to say, okay, I'm marking this directory for version control. And then once it is marked, I proceed on to git add. Git add is to add the files, tell Git, okay, add all these files into version control. So so in here I'm adding git add -- all, which means I'm asking Git to track all the files in this folder. So once all the files are tracked, I can create a branch called master. So -m is for move. So I'm asking it to create a branch called master. So master is the branch that is the main branch. Like, so you might so think of branches as like there is Linux, and then you have multiple versions, flavors of Linux. Like you have Ubuntu, you have Fedora, you have you have Mac. It's a clone of with core Git. So you have a lot of versions of Linux available out in the open, and so Mac is not exactly a clone of Git, but still. So the Linux, the code that goes directly into the Linux kernel goes into the master branch, and the other branches will have different flavors. So here I'm initializing a new branch called master, and I'm asking my local Git to this URL is important. This URL is what defines your repository out in the repository. So I'm asking my local Git to set tracking into this remote URL, so that when I do run a Git push, it goes into this particular repository, remote repository. So once I do the Git push, my code is available. In the version control, and it's available online, and it's now already ready to share. People can contribute to this particular repository as well. So once this process is done, I'd say your basic setup is complete. So I think it's good to follow this particular pattern. This is the pattern that we follow in industry as well. We don't always create a new repo by ourselves. There will be a DevOps team for that, but normally when we start a new repository, we make sure it is pushed up into GitHub or whichever tool your company is using. And now I'll delve a little bit deep into the code itself. So a normal Java CLI app code will look like that. It's straightforward. It'll have a public static void main, and it'll have your code in there, your system.println and everything else. It goes in here. But Android is a bit different. It has a lot of things going on. As I said, most of the people who are really new to Android, the moment they click that button, start a new project, create a new project in Android, they get overwhelmed because there is a lot of things going on here. So in the next slide, I will explain what is each element in the GUI in the IDE. What is each element in the IDE? So at the very top, you have the manifest.xml. It is one important file for Android. The manifest.xml tells the Android operating system about your application. So that is where whatever, for example, what are the screens that you have in your application? What are the services that you have in your application? Everything about concerning what is your app name? What icon should I use for your app? So all that information for the operating system goes into your Android manifest.xml. I will open the manifest.xml and walk through that as well. But that is one of the important files in this particular tree structure. And then your main activity is where your Java code goes. So any code, your logic, your application logic itself goes into the Java code in main activity. And then you have, if you're creating an app, obviously you'll have some images. Like for example, at least you'll have an icon. for your app so that it can be located in the launcher. So those icons goes into the drawable folder under resources. So resources are any external files or any other files that are not actual Java code. To be simple, like to be clear, in layman terms, any other files other than your Java code goes into the resources folder. So drawable is where you, as the name suggests, it's where you put your icons and everything else. Layout is where you define your screen layouts, as in how your screen should look like what is the design of your screen. And then you have bitmaps where you will put bitmaps. And then you have values folder where you will define your constants and everything else. And then you have a section called Gradle scripts. This is a bit more advanced, but on broad term, we can say this is where you define your build scripts and dependencies. Say how, like, what other external libraries am I using for this particular project, or what are the flavors of my app. Say if I have a paid version and the free version of the app. So it doesn't make sense to have two different repositories for the same app for paid and for free version. So you define your flavors in this build scripts. So when you build, and you can see those flavors in this particular section called build variants. That is where you can see your flavors. And then up on the top, you have the view mode. View mode Android will highlight all the Android related files. You can change that to project files, and will show all the files, say concerning Git and everything else in this particular view mode. And then there is another important tool here. It's called the device logs. So device, you can see it at the bottom. It's called logcat. So a logcat shows all your log from the devices. Say if you write a system.println in your Android code, this is where you will see it, or alog.i or whatever it is. This is where you will see device log. And I'll just walk you through the Android software stack, and then we will I'll go to the IDE and show you are the various what are the various part of the code. So if you go here, you go to the Android software stack. Software stack is it's called a software stack because it is arranged as stack. Okay, there was some noise. Sorry. Anyway, so it is called an Android software stack because it is arranged as a stack. So at the very bottom you have the Linux kernel. So this is not very complex. If you just read through it, it's really simple. So it portrays the very important concept in software development called data abstraction. So first you have the Linux kernel, which is abstracted by the layer on top called the hardware abstraction layer. And your hardware abstraction layer is further abstracted by the libraries on top of it and the runtime, which is further abstracted by the Java API framework. And then on top of the whole stack, you have your system apps running. So in software development, layering is when a layer, for example, say Java API framework layer, will only call the components within that layer or directly below it. So our apps, any app you write will go into the namespace of system apps, as in the three dots there, that's where your application will go into. So system apps has a bit more elevated privileges, but your apps will go into a namespace in that box, but not but in a separate box, like say that dot or dot, that's where your apps might go into. So your apps can use the Java API framework to access all the layers below. You can imagine it as driving a car, as in when you drive the car, you don't have to know the underlying working of the car, or is it an internal combustion engine or electric car or whatever. If you press the gas, if you press the accelerator, the car will go forward. So that's abstraction. So when, for example, when in Android 5, I think, like the Android runtime, it was Dalvik and it was switched to Android ART, the new model ART. If you see here, it's called ART. So when that switch was made, you didn't have to rewrite the whole code. The existing, because it was abstracted, your Java API framework did the necessary modifications so that it is seamlessly integrated to your app. As in, your app won't see any difference in the running, except if you are using very core libraries or something like that. So this is the software stack. So we will be using the API Java API framework. So you can see activities, resources, packages, notification windows, content providers, and view systems. So these are the libraries that you will be using for your apps. And if you go into the IDE now, you will see something like this. So this will be your IDE. Uh, so when you go in, first you'll see the main activity. This is where your Java code goes. And before that, this is the manifest.xml. It's a really simple XML file, which says, this is the name of the package. This is the name of my application. And this is the icon that should be used when when the application is displayed in a launcher. And then you have the activity. So these are the activities are different screens. So each screen a user interacts with is an activity. So your app can have multiple activities. Like say if you open Gmail, you have the you have the inbox and you have send an email activity. Like you have various activities. So all those screens are activities. The need for that is that uh, on a desktop application, like you usually have one main entry point, or a CLI application, you have one main entry point. But it's not quite the use case with a mobile device, where sometimes when you click share button, you are, and if you share by email, you are not straight away going into the first screen of the application, but you straight away jump into the send screen of the application. So so that is the need for activities in Android. Same concept is there in iOS as well. So activities are something like that. So here in this manifest.xml, I'm telling the operating system that I have all these screens defined, all these screens in my application. And main activity, you can see it's linked here. So when I click on the launcher icon, I should launch main activity. That is what this particular block of code says. It's an instruction for the Android operating system, or the runtime. And so say I clicked on the icon and then it launched my application. What should I do next? So activity is driven by a set of methods called lifecycle methods, which the operating system calls to run your application. So similar to the public static void main in Java, the OS calls OnCreate method when your activity is first loaded into the RAM. So when OnCreate is called, it asks, like the first instruction that we are giving is set content view to r.layer.activity main. So what it says is, so when this particular class is loaded into the screen, please display the design displayed in this particular XML. So it's simple. So if I click the design here, it just asks, so it is asking the OS to draw this particular screen on a particular template onto the screen. So I have defined. So if I go here, it's very straightforward. I'm asking it to draw a text view with this particular width and height. So if you're familiar with HTML, this is a similar concept. This is also a markup language like HTML. So here, instead of CSS, we are specifying different properties for each of the elements. So say this is a text view with the text symbol calculator, and there are other text views here as well. So say if I want a text box that is editable, then I put in an edit text here. So this literally says edit text, and it has a similar width and height properties. In addition to a hint is to display operand 1 like that in that particular box. And then you also have this particular property called input type. So this is to change switch the keyboard type that is displayed when you click on that button. So instead of since it's a calculator application, instead of displaying the whole QWERTY keyboard, please display the number pad keyboard, which will enable you to input decimals. So all those can be configured here. So this literally, when you looking through this, it's just designing the whole screen. So it designs like a place for the result and a couple of buttons to perform the rest of the operations. So it's a really straightforward way of displaying, of drawing things. So your main activity tells your operating system to draw that particular screen on your phone. And then once you have it all drawn, now you need a glue to get the references of the screen elements to your actual code. For that, Android have helper methods. So this R class is a glue. It's a glue that will fetch you the references from the XML file to place it in layman terms. So in here, I am getting the references for each of the elements in the XML file using using the ID. So here you can see for any element that I need a reference in the code, I'm assigning an ID so that it can be uniquely identified from the XML file. So I'm getting to the first step that I'm doing is initialize the UI elements, where I get the references of each and every element from the UI that has to be manipulated in your code into a class variable. And once I get that, so here I have all the references for all the various items on the screen, and then I can add actions to it. I can assign actions to it. For example, when I press button add, it should compute the sum of the numbers defined in these two text boxes. So that is the code that is written here means. So when the button add is clicked, so I'm asking to set a click listener. So listen to an event, listen to the clicks on button add, and if the button add receives a click, then do this particular set of operation, do this to execute these two lines of code, which is literally just getting the text from the edit text one, from the text box one and text box two. It'll compute the sum of it, and then it will set the result as that result. So set result is again a straightforward method, which is just text, which will set the text of this particular box uh, as a result of the operation. So I have the utility methods here that will just to add, subtract, multiply, and divide. So I'll just run this here so that you can see what it's all about. So if I click run, so IDE helps you to run and test everything. So it will. So so my application is right now loaded into the virtual machine, and I can test it here. So as we ask the operating system, it displays the numeric keypad where I can enter two numbers, and then if I click on add, it'll display the results. Subtract will it'll display the results. So it's straightforward calculator now. Now I'll talk a little bit about what this OnCreate is. To go back to this. So OnCreate, as I mentioned before, it's a part of it's a life cycle method. So when the activity is first loaded onto the screen, it calls OnCreate. The OS calls OnCreate, and then it goes on to OnStart, on resume, and then finally your activity is running. So all these methods are part of your Java API. So when you extend the class application, so activity, all these methods can be overridden to give your own implementation of it. For example, on pause and on stop is when your activity is unloaded or taken out of the memory for another higher priority app. So when you want to save something or something like that, you will ideally be writing it on pause or on stop. And on destroy is when your application is killed totally, so that you have to. So for example, if your application unexpectedly closed, and if you want to start back from where the user left off, you will be writing your fail-safe codes on destroy. So I can talk about this particular lifecycle for a day, but I'm just making you aware of this particular concept of activity lifecycle. So activities is a part of Android API. So, and these are the main methods in the lifecycle. And OnCreate can be thought of as the public static void main in your Java code, and you can write your application, like you can do various things like I've just shown in the OnCreate method. Now going forward, just going into the code. Then, and another important thing Android, the Studio lets you do is it also helps you to define the test cases. For example, it's important to have unit tests. So you can have your JUnit for tests. So test in your this thing, and you can test various code by just clicking run here. It'll run all your tests, and it'll show your results at the bottom as well. So if I've started the test, so you can see what all tests pass. It's a very important. So a software that cannot be tested is flawed, basically. So you make sure when you write code, it's always testable. So these are your unit tests, and you can also have your integration tests written here. So this is instrumented test, as in it will literally load your app into a virtual device, and then it will perform the tests automatically in your virtual device. As in, if you walk through this code, it will literally load your activity. It will set the text boxes with the particular values, and with the software and the like, you can think of it as a bot. It'll literally go and click on different elements of your application. This is an important concept in UI testing. For example, if I run it here, it will load the application and it will perform the tests. So it is completely automated. So it enters, it clicks add, and it checks the result is correct or not, and then unloads application. So this is instrumented. I'm using the built-in test class called as Espresso, so or Android JUnit 4. So so Espresso is the test framework that is for running instrumented tests. You have one more framework called the UI Automator, so you can use that as well to write your test cases. So this with all this, you should also remember to have your version control checked in. Like for example, I have hosted this application in this particular place in my particular repository, and you can have pull requests for each of the features that you develop. For example, when I first did my main screen design, I pushed it up. So I checked in my code here with my main screen designs, so I can see what all files were changed in this particular. So this is called a diff, as a difference in the file. So you can see what all files were changed and what were the content, and you can review the code as well. You can, like, if you have multiple people are contributing to the code, you can add comments here, and you can have a discussion going here, and everything is captured. You don't miss anything here. And you're like, for example, your professor can have the comments here for code reviews. And so this is yes, sorry. Yeah, so this is when I had the main screen design. This is when I had the math functions, and this is when I had the calculator functionality integrated into the application. So from further comments, I can do this as well. For example, when I wrote the math function, I also made sure to write the unit test. So I think most of you will be familiar with the terminology test-driven development, or TDD. It's when you write the test first and then you write the code. So it's a good thing to follow. So write a failing test first, and then you write the code to make sure the test works. So that way your code is properly testable. So you have the test here, unit test here when I first developed the math functions, the utility class. And then when I had the calculator functionality itself, I made sure the feature is captured with instrumented in the integration test here. So you can see the changes in application. Like this currently is in a public repository. I'll share this URL along with the slides if people are interested, and they can. So I have a couple of code here as well. If you want to contribute, make better, something like that. So your to-do app as well, you can do the same thing with that. So that's a little bit about the testing side of things. And so once you have your application developed, up and running and everything, then you have to publish your app. So the next step is for publishing your app into Android Studio, like Google Play Store. So this particular URL is where you go and create an account, get a signing key, and publish your app. It's a bit too much to discuss it right now, but it's a straightforward process. Again, it's all well documented in Developer Android Studio. And then this is so in industry, when you have a lot of people contributing towards your Android code, you follow these three terminologies. It's often coined as CI/CD/CD. So CI is continuous integration, where your changes, like your master branch, is a single source of truth, and your changes are constantly merged into the master branch as often as possible. So when you make a change, immediately you somehow commit into the master code. That's continuous integration of code. And then you have continuous delivery. Continuous delivery is when your code is what the code that is delivered, that is integrated, is immediately built, packaged, and delivered as an installable unit, as a deployable unit. And this is mostly most of the companies practice CI and CD, and bigger companies where the software is too big, for example Netflix or AWS or Ericsson and stuff like that, they go one step further and they also do continuous deployment, where continuous deployment is the test cases are solid and so trustable that you can straight away deploy your code that you developed into production, where users can immediately use it. A normal pipeline in any typical release pipeline in most of the companies will look like this. So the developer commits the code, and you go through a code review process where your peers, like your colleagues, will review your code, point out the mistakes and everything. And parallelly, a set of unit test is automatically executed by the version controls by the CI/CD, the pipeline. And once this is okay, you once everything pass, once everything is green, you merge your code into the master branch of your CI, of your version code or source code management system. So once you merge into the master, the pipeline, the next step in the pipeline is it'll automatically deploy it into a test environment, and it will run integration test, like similar to what the test I just showed you, where it'll automatically load the app. It's a black box test, so it'll just press the buttons on your app and everything, and it'll run the integration test. And once integration test is done, it is assumed that your application is ready to release. So, if it's a green, then and not a watermelon code, a watermelon code as in it's green on the outside but red on the inside. So if it's not a watermelon code, you will get it to be released immediately into your staging environment. So test environment, staging environment, production environment are usually the three environments available in your development cycle. So once you deploy to staging, it will run as a separate set of test cases called acceptance tests, where it's again one more step of abstraction. It goes one more step beyond, and it's a longer running test cases, like longer running tests for acceptance tests. And also you have to run regression tests. Regression test is when your version of the software, the tests that your version of the software is running is also like is executed against the previous version as well. As in, is your new release compatible with an older version, like older version of the software? So that's where you need regression tests. And once the acceptance test or regression test is done, you normally deploy it into the production, and then you do things like canary releases. And this is a relatively new terminology, canary releases, and alpha beta tests, and etc. So canary release is when or A/B testing, as you might study in academics, is when you release your software to like 10% of the users and match the performance with 80, like with your older version of software. And then you'll also run alpha and beta test after you deploy to production. So to deploy to production, your test cases to be so robust. So as you can see here, tests are really important. So your code commit and code review ends here. Rest of the whole pipeline for the company is dependent on your tests. So the more you practice TDD, the better the better it will be when you step into a company. So the more you practice code reviews, code commits, and version control or source code management, it'll be easier for you to integrate into any organization. And I'm also suggesting two books. I see two of my teachers here, so I hope this could be like, I'm just suggesting two books for everyone. Maybe the library could give this as well. These are two really nice books. It's two of my favorites: Art of Readable Code and Clean Code. It is the good practices of how to write the code and everything. And then try it yourself, like as in I'm almost towards the end of my session, so you can clone the simple calculator application, and then you can try running it in your own device, and you can try making it look like a handheld calculator. I have left some to-dos in the source code, so you can maybe modify that and do a little bit of hacks here and there to make it customized or something like that. Or if you are really comfortable with the calculator application, you can try building a to-do list app, and you can use the exam stack to have a server, and then you can use a library like OkHttp client or something like that to save your to-do list constantly to save your to-do list on a backend server and to your local device as well. So this is just like a homework. Okay, I won't say homework, but this is something that you can try out in your own time. And with that, I'm concluding my session, and I'm opening it up for the Q&A. Thank you for listening to me for an hour, I think. And yeah, so please do let me know if you have any questions. You can either text here, or uh, you can ask me in the mic as well. So I will stop presenting now.
So it's the Q&A session. Now you can all ask your doubts and questions in the chat box or using your mic. Meanwhile, the others can fill the feedback form in chat box.
I guess I was too fast. Okay, got a question here. Which would be better for a starter, Kotlin or Java? So I'd say if you are totally new to the environment, yeah, you can try using Kotlin. Kotlin is a good one. Flutter is also a good framework. Yeah, just heard it here. So you can use Kotlin. It's easy to learn Kotlin as well. But if you're already familiar with Java, then I'd advise start developing with Java and then move to Kotlin. Okay. So
Sir, I have a question.
yeah, go ahead.
Oh, okay. Sir, it was an informative session, but my question is, how secure would my application be if I make use of Android Studio to develop my application? And
Sorry,
I've heard that Android offers something called Jetpack.
so you're breaking up. I cannot hear
So
you
how
clearly.
secure would my application?
Mhm.
Okay, so then I'll post it in the chat box.
Okay. So I get another question here. I did not understand what the build files do for the app. So build files are where you develop, like where you write your build steps, as in how to compile your application. Say you are using an external library that, so you're using functions in an external library in your app. So you're importing like an external library that you downloaded from the internet. So build will optimize. Build will compile your application first. It will optimize your application. It'll decide, so you can decide which all files will be packaged into your deployable code. So the build step will actually compile and package your application into a deployable or distributable code, distributable file. Like for example, for Android, it's an APK file. So the APK file, you can that's a unit of file. That is a unit that you can deploy into any phone, or you can publish it onto the internet. So that is what the build do, and various steps for that can be described in the build file. So Gradle is the one Android is using. There is another other build tools as well, like Maven, for example. It's very common among Java developers to use Maven. Uh, and another use case for build is when you have a free app and a paid app. So you are sharing the code base with your free app and the paid app. But when you build against the free app code, it will only include the files that is required for your free app. And when you build your the paid version of the app, you'll include more files and more resources, and you will cancel the you will omit all the advertisement stuff and everything from your paid app. So that is another use case of multiple builds. So you can have any number of builds like that. So all that is configured using the build files. And then I guess somebody asked me about security, but I wasn't sure on what kind of security was being asked for. I hope that cleared the question, the build files. Okay, another question is, for a beginner, what are the ways to learn coding in Android Studio, books, blogs, or other resources? So you have multiple courses in Udemy if you prefer Udemy or plural side of things like that, if you prefer an online tutorial. But everything you need to, like, personally, I learned Android development through the developer.android.com website. Like, everything you need to learn Android development is there in developer.android.com. That's why I introduced that website. And it also has a Hello World tutorial where it has online documentation on uh, how to how to get going with your first app. And then you can delve deeper as you delve. But the most important step is to actually write the code instead of going through the tutorials or watching some videos. Yep.
A little to add to that, I think instead of spending money in the initial stage on Udemy or plural side, I think there are plenty of resources in YouTube for free. Maybe start with that. If you are following one tutorial, stick to it. Like Sachin said, keep coding. That's the best thing. That's the main thing you have to do. There is no point in just going through the tutorials. You have to write the code, you have to run, and you have to see the output. That's the main thing.
Totally. Yeah. I'm sorry if what was the question on security again? Okay. And please do avoid calling me sir. I'm not. Yeah, please. I'm just your senior. That's all. Please do avoid calling me sir. So I guess I will leave my contact details, and then you can get to me anytime for any queries.
Thank you, Sachin. Thank you. Thank you so much.
So we have come to the end of an informative webinar. I thank the speaker of today's webinar, Mr. Sachin Murali, for the really edifying session, and also the GECW Alumni Association Bangalore chapter. Also, Shabisa for giving us the opportunity to host this event, and Gilesh sir for your presence in this webinar. The event won't be complete without all of your participation. So I thank each one of you for attending this webinar. So see you all next week. Bye.
Bye bye.
Bye. Thanks, Rad, and all the best.
Bye, guys.